Hello, this video will briefly explain how an RCD works. An RCD is part of an electrical circuit, and I'll quickly talk through the general principles and workings of an RCD. This would be a good example to see how an RCD faulted out, and I'll show you that one now. So this little bit of lint faulted out the RCD on a domestic circuit via an appliance, and the appliance here today is a domestic dryer, a tumble dryer, and the RCD was governing this heater element, which is like so. It's attached over there, and how that works is air is drawn over the element and then back into the drum like so. So it goes in that manner, like that way. And then during that process, a little bit of flint just got stuck down there like so, and then it in turn bridged that element to the chassis via that backing plate, and then that was enough to trip the RCD because it was outside the governing limits. So it's actually difficult to see in real life RCD faults for most cases. So I just thought that was a really good opportunity to see it. So there's something physical there you can actually see in this case. And again, quite often not, you can't physically see where the RCD fault is. So this is one example where you can. Now this is a quick little guide on how the wiring works of an RCD. So this is very roughly drawn out. So this would be one example. So very roughly speaking, this is how you could get to understand an RCD. So hypothetically, let's just say your circuit, just envision this as one circuit. Just assume there's nothing else attached to this circuit or in this one motor. So let's just say the motor is governed first of all by an MCB of 20 amps. That today is quite irrelevant, but just for the purpose of the circuit, I put it in a noise. Now, this is the one we really want to delve into. So this is the RCD, and this one is governed by 30 milliamps. So this is the one we're going to speak about. So now, off we go. So this in turn, so the MCB in turn feeds the RCD, and the RCD then feeds the circuit. So the RCD governs what is allowable within the circuit. So how it works is something of this manner. So current is allowed to flow through the circuit, and it flows in on the live, through the motor, and then back on the neutral. And the neutral then is allowed to pass through the RCD and then back into the fuse board. So if it detects an imbalance between the live and the neutral outside the limit, it will trip the circuit. So to put some figures on that, let's just say this motor draws 4 amps. So 4 amps is allowed to pass down through the live into the motor, and you should be able to read that current on the neutral as well, because it is all one circuit. So that neutral then in the case such as that will go back here into the RCD and back into the breaker board again, and it should be 4 amps here also at that stage. So 4 amps in the live, 4 amps out in the neutral. And the RCD then is monitoring this 4 and 4. Now if there's an imbalance between the 4 and 4, the RCD will trip. And if that imbalance is more than 30 milliamps, it will trip in this case, because it's a 30 milliamp RCD. And in perspective, 1 amp is equals to 1000 milliamps, And in perspective, if there was no RCD attached, you can have a discrepancy between your live and your neutral, and current. And current is something else I'll explain in the future. But we would accept, let's just say, if you got 4 amps in to get 3.9 back, that's okay. Where there's no RCD attached, and when there's different applications and different variations. But in this case, if you're sitting down 4 amps and you're getting 3.9 back, that doesn't sound like much, but 3.9 would be equate to 1000 milliamps of an indifference. And considering the limit is set at 30, that's quite a difference. So that shows in perspective the sensitivity to this. And the lower this value is, and the less on the shock scale you'll be getting. So 30 amps is deemed reasonably safe, so that's why it is set so low. And this is just a quick little guide on RCDs, and I hope it was helpful. Okay, take care.